Okay, so welcome everyone to another session at this GSC UK virtual conference. This last session for today is session 5AR with renowned Bob Rogers, and he will be talking about addressing the installation exits problem. Now, you should all be aware that for any questions, please raise them in the chat box, and at strategic points throughout Bob's presentation, Bob will be answering those same questions. So Bob,
thank
the
you
floor
very
is all
much.
yours.
As I said to Joe and Rui before we actually started the presentation, this is great hubris on my part to talk to systems programmers about system programming, when even though I've had a very long career, I've never been a systems programmer, and I've always been on the other side of any kind of installation exit point. But I think it's a message that has to get out. Maybe it's preaching to the choir, but we'll see. Why is this not moving? Okay, there it goes, just slow. Anyway, as many of you old timers know, that the idea of customizing with installation exits goes back to the beginning, and was sort of justified when OS 360 was brand new. There was so much functionality that IBM wanted to cram into it, that there's a lot of stuff that they couldn't get into it. So they copped out and said, well, let's let the installations augment the operating system with some code of their own to tell us exactly how they want things done, because we really haven't got the time to provide a decent user interface for these kinds of specifications. So even though, I would say it was justified in 1964, it is kind of, I don't know, absurd that an awful lot of this customization through having the installations actually write code still persists to this day. As you'll see later, IBM is kind of chipping away at it, but it's quite a large mountain. And this exit code typically is written in assembler language, although, again, there's some movement towards allowing some things to be done in Rex and so forth. But for the most part, it's in assembler language and runs in an authorized state. Gotta somehow get this bar off my chart. Can't. Anyway, so the situation that we have, if I'm correctly guessing at what my last bullet says, is that installations get to specify things like JCL rules and other policies by writing code that runs in an authorized state that can crash your system. It doesn't sound like a really ideal situation. So as I said, even now, we still have a lot of these exit points. And in time, the level of skills in assembler language has diminished. I mean, to a great extent, they've diminished because they're not really needed as much, because most mainframe users are they're buying applications instead of building them. So they don't have to have a lot of skilled assembler language programmers in-house. Even if they still have some of their own applications, they're probably written in COBOL, not assembler. So we have this first problem, that you have to be pretty good in assembler language to deal with writing these exit modules. And I consider it to be a worse problem, that knowledge in the the parts of the operating system and the related products that's on the other side, on my side of the installation exit point is perhaps even more diminished. A lot of us old timers learned about the operating system and other things from microfiche before starting with this OCO policy. I think back in the 80s. So there's a lot of people that haven't had an opportunity to view a lot of the operating system code to understand what's really going on under there in order to properly and correctly interface with those parts of the operating system. And it turns out, and I don't mean to badmouth anybody, but through unhappy circumstances, there actually are installations that don't really know much about their exit code, that whoever it was that was taking care of it has retired or worse. And now they're left, kind of struggling with, well, what have we got? And of course, well, if it's not broke, then you don't have to worry about it. But things do happen through time that make good code go bad. So I've really already told you kind of why I'm giving this presentation, that now would be a good time to try to, step up to dealing with these issues before they get any worse. Because, more and more of the old timers, people who already know things are retiring or whatever. And there's a lot of stuff that you have to know. I was poking around, using Google to look for documentation, and there's a lot of documentation about what you need to know in order to write these customized exit routines, which of course, I mean, if you've been learning things and keeping up with it, the analogy I use is like to a soap opera that, for those of us who started watching Guiding Light when we were very young, sorry for the reference that might not be understood in the UK, there's no problem in just, tuning in and watching a new episode. But for those who missed the first 30 years of it, it can be a problem to understand what's going on. And I think the same thing is sort of true with all of these aspects of the operating system, that those of us who are around for a long time have accumulated a lot of knowledge, but younger people not so much so. Yeah, I wish I could figure out how to get this bar down so I don't have to see it. So there's a number of solutions available. There's ISV products, and there's even some new capabilities that IBM is providing, which I'll touch upon later on, but it was covered much more thoroughly in a presentation last year. Okay, So anyway, I say something about ZAwesome on the last bullet, but I really can't see it all, so you'll just have to read it. Sorry about that. I guess what I could do is get out of full screen mode and read it. Okay, I just wanted to mention that although this is not a product sales presentation in any way, I will use examples from Trident's ZAwesome product to demonstrate, one approach to, being able to retire the exit code and not have these problems or worries. I call them worries rather than problems as things go forward. So here's a quote from the SMF manual, and some of it probably applies to other aspects of SMF in terms of what kind of knowledge you have to have. But they do point out that you need to code an assembler, and I think that is directly addressed at the fact that SMF has exits. I don't know anything else about SMF in terms of specifying the parameters and interpreting the information or whatever, that actually would require assembler language. It's just the exits. You need to be able to read assembler. You need to be able to, basically go through the code development process of link editing and so forth. That's what they say. And here, I'm telling you what you probably know even better than me. These are some of the kinds of things that somebody would have to know in order to be able to successfully create and deploy an installation exit to customize their system. As has been said many times, you need to know some assembler. You need to understand the policy that you're trying to implement, which might involve some understanding of how the operating system works. There's books available that'll show you exactly, like, when you write the code, this is what you get in register 1 and so forth. And this is how you return whatever results you want. That at least can pretty easily be gotten out of the documentation. And then you need to know from from an operations point of view, how do I bring up a system and run some scenarios, some variations in order to determine that the exit that I've created or the exit that I've updated, or even the exit that I already have unmodified, still does what it's supposed to do in all the cases. And to do that without blowing the system up, which is certainly a possibility. So here I just list some of the things, some of the impediments, I guess, on the way of, somebody new coming in, even if they're, very smart person, has a pretty good background, given, how long they've been in the industry. There's still quite a bit that they need to learn, become proficient in order to be able to create a working exit routine. And there's a lot of documentation that has to be gone through. For example, the JES 2 installation exits manual is 500 pages long and describes 60 exits. And that's just JES 2. Doesn't include SMF or the couple of TSO exits, a couple of RAC-F exits, and so forth. But JES 2 is certainly the biggest one with exits. So just as a very simple example, and again, such hubris of me, I've never been a systems programmer, I'm going to tell an audience of systems programmers how to write a submit exit. But anyway, it's a simple example. And this exit is called, in order to look at the JCL that some TSO user is trying to submit, to have read into the system and have the job execute. It runs in supervisor state, which makes it, kind of like, don't make any mistakes. But they're nice enough, IBM's nice enough to provide a sample, but the sample doesn't really do anything but all of the housekeeping that has to be done in order to properly write an installation exit. I'm going to show you a list of all of those activities probably on the next chart. And there's a bunch of things that you could do in an exit routine at this point in an IKJEFF10 exit. So if you own one of these, but but haven't written it, these are the things that you'd have to look for, as you're trying to read the assembler language that somebody else wrote. And then you have to have a different set of skills in order to figure out how to bring up a system and test it, typically on a test LPAR or using ZVN. And here's a list which I cut and paste out of the prologue of the sample called IKJ exit. And you can see there's a lot of, and some of these things probably don't have to be done, like number 9 to print all the parameters. That's probably just when you're running the thing in test mode. But anyway, these are a bunch of activities that typically one would have to do in an exit that don't actually accomplish any of the things that you wanted to accomplish. This is just the necessary framework. Another thing is that if you do avail yourself of some of these IBM samples, you also have to keep track of, like, were there any APARs against the sample? So let's take a look at the thing that makes the flower box at the end of steps and jobs. The sample is over 1,200 lines of assembler code, and you can use that as a starting point to customize for whatever reason you want to customize it. Now, IBM updated that sample because basically the processors got so fast that it was possible to run SRBs that consumed 0 CPU time. You might even actually execute the job. I suspect something like an IFBR14 might not use too much CPU time. So anyway, on the next chart, I think I even have a copy of the fix to the problem. But anyway, so this is something that you kind of have to keep up with, is that, okay, do I need to make an analogous change in my customized version of the IF-ACTRT exit module? And as I said, it's just upgrading to a faster processor can all of a sudden make this start to happen when it didn't used to happen before. And then, looking at the change activity in the SMS exits manual, I did not look up to find out what are all of these things. Are they really important? Are, some of them things that you really need to react to, or are they opportunities for further exploitation because there's new features or new data available? But, this is something that probably somebody should look at every release and determine whether or not that it motivates any action. So even if the answer turns out to be no, you don't really need to do anything, you've already done something, which is to expend the resource on the research. And the research needs to be done by somebody with sufficient background to understand what these update notifications are saying. Anyway, on the positive side, now that I've been pretty negative, on the positive side, IBM has been doing a little activity in order to eliminate the necessary to write assembler language exit routines. Now, I personally don't think they came up with a really great approach to how to deal with this, because I'm not a big fan of specifying stuff in ParmLib. And I confess, I don't even know JSON. But anyway, in recent times, most recently, IBM introduced this thing called JES2 policies to replace the assembler exit code, where you can create a JSON document which basically expresses your policy. They're doing this incrementally, first introduced in 2.4, but in 2.5, they augment, they move further, they advance their chipping away at the need for JES2 exits. And they also, in previous releases, provided, or I don't know, maybe it was finally, RACF has a way of specifying the names of the RACF data sets without having to write code and link edit it into a module. And also, a couple of releases ago, I think this was even before I retired, but it might have been after, because I kept giving my goodie bag presentation even in retirement. There's a ParmLib member that you can specify how much virtual storage different jobs can be allotted in various circumstances. But they did miss the fact that there's also data spaces and hyperspaces. But anyway, so this is something that, some people might feel is a better way than, than actually writing code, but it's not great. And I got my knowledge about this from looking at the charts from Mike Sorkin's presentation last year to your conference, which I, of course, did not attend. But anyway, I would advise anybody, if you haven't seen it already, to take a look at Mike's presentation. It's very informative about how to, chip away at your requirement for assembler language exits. I decided I'd put a chart in on JES2 policy, not because I know anything about him, but because of the bad mouthing that they do of the concept of writing assembler language exits. That they are kind of in my camp on writing assembler code in order to customize your system is not in the 21st, in fact, in the third decade of the 21st century, not a particularly appealing idea. But they require the definition to be put in this language JSON, which, it's nice that they do something that will be quite appealing to younger people who are already conversant in these newer technologies. But it makes kind of like a chasm. There's a bunch of people who maybe don't know JSON, but they know JES2, and they know the installation's policies. And then there's the shorter tenure individual who knows JSON. But anyway, that's something that, if you want to get into that, you can deal with it. So my judgment of JES2 policies is it is a movement in the right direction, because at least you probably can't blow the system up by making a mistake in your JSON. But it does require that you write in a language, even if it's not said to be a programming language. So this is, again, me sort of, I'm the student preaching to the professors on this. But anyway, in order to, kind of get out of this situation of having assembler language exit routines that knowledge of which is evaporating, the first thing you need to do is to find your exit code. What exits do you actually have that you've implemented? Now, one of the pieces of news in this presentation is that the company Trident Services has created a utility that'll go into your running system and will fish out information about all of the active exit points for the elements of the ZOS product, and also related products like JES2, excuse me, like actually I could say JES3 is a separate product now, like RACF is a better example. And then having identified the exit routines, and then I probably should have put this next phrase in like ultra boldface, locating the source code, because you will have to, in order to find out what your policies really are, you have to look at the source code. Even if you have written documentation, you need to verify that that's what's really implemented, because maybe the code was updated and the documentation was not implemented. And it turns out there's a fair number of installations that don't actually have any sort of all-encompassing documentation on how they've customized the system with these exit routines. And once, again, this is a bullet I can't read. Once the installation policy has been determined, then you can try to replace the exit code with something from a software vendor product, or you can start using the ever-growing number of things that that IBM is providing to try to mitigate the problem. Okay. Oh, look at that. Michael told me that the SMF Lim XX member to replace IEF USI came out in ZOS 2.2. Thank you, Michael. But anyway, I'm sure everybody's at least on 2.2. Okay. Okay, so here's, I mean, in many ways, this little tool is very unexciting. But the thing that's exciting about it is that it's tireless and extremely comprehensive in its search for exits. It looks for 500 exit points. And in the report, it groups these exits according to kind of like the ZOS element or a related product that that provides that exit point. And you know, it lists the obvious stuff, the name of the library, the name of the exit, and so forth. And then as to give a clue, it provides a printout of the first 80 characters of the load module to give you some idea of where it came from. And hopefully whoever provided the exit will have put something in the first CSEC of the load module that kind of identifies. For example, if you look at the first listing here of IF ACTRT, you can see that, boy, this looks like it comes from IBM. Because, you know, this header information looks an awful lot like what IBM does. Now, it turns out that this happens to be one of the CSECs in the load module and not something that's specifically there to identify the source. But you can sort of, you know, tell that this module came from IBM. Now, what you can't tell is whether it came, you know, if it's an unmodified sample or a modified sample, but it does give you some additional information. And then down at the bottom, it gives a summarization of the exit points for that particular category of exit, like JES2 or TSO. As I said, it's quite unexciting. And then here's kind of the laundry list of the, you know, the information that they provide for each exit point. And hopefully this will give a very good start on the search for all the source code for all of these exits. Now, a lot of the exits you'll find are actually, the module is actually provided by a vendor. And hopefully in this listing, the, you know, either the name of the library that came from or the 80 characters from the load module will let you know that. So there's a lot of exits, so you don't really need to worry about too much, because hopefully the vendor who provided you with the exit will give you a PTF or whatever they're calling it, a fix for any issues that arise within that exit because of a new release of ZOS. Okay, so anyway, here's the laundry list of all of the domains, if you will, that provide exit points that a customer can write code and attach to. I took this chart from a different presentation where I highlighted the ones where just by happenstance, the ZAwesome product happens to address. You can see there's a lot of areas that it doesn't address, but it does address some of the most important ones. And then, you know, just to encourage you that, you know, this is not really onerous. The tool itself is distributed as a terst file, provides, you know, JCL examples for unloading the tool onto your system. Unfortunately, because of what it does, it has to reside in an authorized library. Also, with the download package is a user's guide on how to run the tool and interpret the report. And you can request this package with the tool in it by just sending a note to that email address, and you'll be accommodated. And that way you can get started. You can at least see like how deep the water is in terms of, you know, how many exits do you actually own code that attaches at these exit points. Now, once you've done the miraculous work of actually finding the source code for the exits, then you kind of need to look at it, to read through it, and determine what your actual JCL rules and other policies are. Even if you have documentation, as I said before, you know, you might want to do some level of validation that the documentation is really doing what the it documents what the exits are actually doing. And, you know, if whoever the vendor is, if you're using a vendor product, or IBM in the case of trying to use the IBM capabilities, I'm sure that they might be willing to give you some sort of help in making the transition so that you can retire your assembler language exit code. And then, yeah, once you know what your policy is, you can then recast it in this non-programming way and activate it, and life will be good. So as I said, I would use the Z-Awesome product as an example of very convenient and usable ways of eliminating the need for custom written assembler language exits. That the approach that this product takes is to have ISPF panels with values and radio buttons and so forth on the screens that allow you to express your policy in a somewhat more human way than, you know, looking at inputs and then massaging those inputs in your exit routine and then giving something back to tell the operating system what you want. And the policy is defined using these ISPF panels, but it's separately activated so that you can, you know, you can make changes. Or something that I find to be an extra bonus is if anybody's curious about what the policy is, you can just pull up the panel and take a look at it instead of having to dig into an assembler language routine in order to find out what your actual policy is. And the policies can be activated later and done so without re-IPL or recycling any of the subsystems. And if it turns out that there's some like really exotic customization that your particular shop has done that the product doesn't handle, you can daisy chain in a much reduced in size and complexity exit routine that would work in tandem with what the product's functionality is. Now here's an example, and I picked on ACTRT because, for one, it provides a sample. And it provided a sample, which later on had to have an APAR against it, which I've got the fix is highlighted in blue. As I said before, this IBM supplied skeleton is like over 1,200 lines of code. You can go in and make your own modifications to it. You probably can even use it unmodified. And hopefully you'll apply the PTF when it comes in to avoid that particular program check. And on the right, I have, much too small for you to see, a panel from the product, and it controls a whole bunch of things that you want to happen, and they can be specified by job class in this case, including 8-character job class names, which was something that's relatively new in JES 2. And you can request, for example, a message when a job ends, a message when you write a WTOR to an operator asking the reason why the operator's canceling something, and so on. And then whether or not you want one of these flower boxes. In this case, I guess for some reason, for job classes A and B, they don't want flower boxes. Now, maybe they're the kind of job that doesn't make any sense. But anyway, that's just to give a little flavor. I'll have more examples later. And here's pictures of the flower boxes that get produced by just saying yes in the right column. So that was, fairly convenient. And of course, the vendor will, apply any PTFs that are required in order to, make sure that that their functionality continues to work with the latest release of ZOS. Of course, like most vendors, IBM has a early support program that many, probably most of the important independent software vendors participate in, so that they get the code for the next release before it's generally available, so that they can, exploit new capabilities, and also to make sure that all of their stuff still works with the new operating system. And of course, once you've gone through, this effort, and I'm not claiming that it's really simple to make the transition, but once you've made the transition, then you're basically done, because you can then, specify your policy in ZAwesom's ISPF panels, or in the non-programming language JSON for the JES2 exits, or some other vendor product or whatever. But once you've done that, the new support comes kind of automatically, because hopefully the vendor or IBM itself will make sure that things continue to work as you go to new releases. So you really, the worst thing that would happen is that you have to put on, either some IBM or ISV PTFs as you go to the new release, but you don't have to, go in and re-review your exit code, because the capability of doing that is getting smaller. And there's a lot of other things that system programmers could productively be doing, rather than going in and making sure that their old exits still work. So now let me just lean over to my phone to check the time. We're doing pretty good. I'm actually going to have quite a bit of time left, I think, because I don't want to go into a huge amount of detail on these examples, because this is not intended to be a ZAwesome tutorial, but just to give a flavor of how one can do activities, that previously were done in assembler language installation exits. So from the main planner, you can see the product does a lot of crap, but you get into extended functionality. And then suppose what you want to do is to control the use of particular sysout classes. You might want to make sure that certain sysout classes can only be used by certain jobs, which of course will be classified some other way. In this case, in order to implement this capability in the JES2 exit 6, you do these things. I'm not even going to bother to read them all, because it's kind of immaterial, but you can see that, well, there's a couple of bullets there. And in preparation for doing this, you will have stored your information, which determines how the decision should be made, into your security product, so that it's sort of centralized there, instead of having, like in the old days, some sort of like load module that would then be loaded by your exit routine and then scan through in order to find, the appropriate information for making the decision that it currently needs to make. So instead of doing something like that, taking advantage of a database that you already have, which is your security product. And so if you were to write code to do this, you would have to, invoke the security product and then evaluate the answer. And it's estimated by a much esteemed development programmer that I know to be about 200 lines of code. And a lot of it is, that sort of housekeeping stuff that I showed you some charts back in relation to the IKJ FF10 exit. Certainly the actual working meat of the exit is not going to be a whole 2,000 lines of code, but you do have 2,000 lines of code, many lines of which can have errors in them and cause problems for you. But if you were to, take this ISPF dialog approach, you basically just have a couple of numbers. And of course, you probably wouldn't do it that way. You probably would work your way down through, as I'm showing in this chart. It's not really that important, but it just shows that, as you go down through the hierarchy of ISPF panels, you can select what you want to do. And then finally, you get to the working panel where you tell the product how it is that you want this decision to be made. And you're saying basically that you want to, you've used a facility class and with a resource named sysout. And for these different job classes, you want to have it validated that those job classes can use the output class. And I like when I saw J as an example, I thought it'd be good to put a comment in to explain what sysout class J is, which is junk, but we still print it anyway. Okay, another example would be controlling the job submitted from TSO. There's actually two activities that we want to try and do here. Both of them would go into this IKJ FF10 exit. And you want to make sure that any job submitted starts with the first six characters are the submitter's user ID. And if not, you make it so. And the other thing is to make sure that the user has the authority to use the particular job class that the job is being submitted into. And if not, then you want to blow the job up. And again, this is expected to be about 2,000 lines of code, most of which is, busy work, but still it's substantial. Or using the ISPF panel approach, there's two different paths that you take to get to the working panels in order to specify what it is you want. And this one is for, like what to do with about the job name. And what you want to do is have 6 characters of the user ID replace, if necessary, whatever is currently in the first 6 characters of the job name. And yes, you want to do it. Pretty simple. And then for the other activity, you're going to invoke the security product of the facility class and check this particular resource. And that's going to determine whether or not the job that user is allowed to use that particular job class. And it's all encoded in an easily validatable place in your security product. This is my last example. So I'm going to be swimming in extra time. Controlling jobs, another controlling job submitted from TSO. This one is to, now I believe that, well, anyway, never mind. I'm not going to tell you anything I believe. I'm only going to tell you what I know. So you want to make sure that jobs don't execute any longer than what was specified in the JES2 job class definition. So again, you're in IKJ F10, looking at the JSON. And remember, the thing is, It would really have been nice if somebody parsed the statements for you. But the reason why, the number of assembler lines is, measured in thousands, measured in Ks, is because you actually have to parse the JCL statements in order to find the thing that you care about. So like for the other ones, you would have had to parse for class, for example. You don't really have to parse for the job name because it's in a fixed location, but you would have to parse for class, for the job class. And for this, you have to parse for time. And of course, there's continuations, and the code gets pretty elaborate. And in looking at a large amount of exit code, which I've done, it's onerous for no really good reason. But anyway, so you've parsed through and you found the right parameter, and then you look at the value specified, and then you want to compare it to what was in the JES2 job class definition. And I guess if it's too much, if it's too high, you want to blow the job up. And it's good, of course, depends on job class. Or alternately, you have this path to this particular panel, which allows you to specify by job class, how you want the time parameter to be handled. And that, I think, is it. And we have some time for questions. I'm going to find out how to get up the faces of my comrades here.
Thanks, Bob. Another excellent presentation to wrap up the first week for the Large System Stream. Do we have any questions? We've got some time, so fire them into the chat or shout up. We could potentially even unmute one or two of you if you wanted to ask something. Fire away.
Okay, now I can see Joe. That's good.
I'm still here. I'm still here.
Because I couldn't see myself during the presentation, I hope I didn't make my face too big.
No, all good, Bob, all good. Yeah, sorry about the annoying Zoom bar getting in your way. There's not a lot you can do about it.
Well, it appears that the presentation was either inscrutable or perfectly clear.
There we go, getting some positive feedback there. Great presentation. So yeah, sign of a good presentation.
Oh, thank you
No
very
questions.
much. Always my pleasure to work with my friends in the UK, but next time I'd like to come over.
Yep, yeah, definitely. Don't we all? Yeah, it feels like beer o'clock now, Bob, right? So yeah, and yeah, unfortunately, no, all virtual. Now listen, everyone. Look, I'll wrap it up there. Thanks. That wraps up the Large System Stream for this week. We're back at 9 o'clock on Tuesday, I think. So until then, have a really good Friday, a really good weekend, and we'll see you all next week.
Great.
Cheerio.